Welcome to the Good Christadelphian Talks Podcast. I'm Levi.
And I'm Chris. Thank you so much for joining us this week.
On this podcast, we select one talk a week to help each one of us get the Bible in our daily newsfeed.
We post at the start of each week for you to listen with a short intro beforehand to kind of set the stage for the talk you're about to hear.
And now, let's hear more about this week's talk.
For this week, we're listening to a talk that was given at the Watchon Lake Bible School just last year by our brother Dan Robinson. This was an evening program that he gave, and the topic of his class is Stand Still and Consider the Wondrous Works of God. And what Brother Dan is taking a look at in this class is the proof in the world around us that there is a creator. This is a topic that I feel many people may have heard similar classes to, talking about how the complexities in the world around us prove to be more evidence of the fact that there is a intelligent designer behind some of the things that we see in the world around us, rather than things that just randomly happen to come together. I really enjoyed the way Brother Dan took a look at this. So one of the examples that he uses, and in the class, he makes references to videos and some slides that he's put up on the screen. And in the beginning, you kind of feel like you're starting to lose something, but he ends up describing what you're seeing on the screen fairly well. I thought I was able to follow the class really well without being able to see the content that he was putting up when he gave this evening program at the Bible school. But what was unique about this one is he goes to one of the examples that is often used in kind of conversation of the eye being an example of how complex the human eye is. And what made it unique in this case is Brother Dan is an optometrist by trade. He is an eye doctor. So he spent a lot of time looking at different eyes from different animals and how much variety there was in the different eyes, and then spent some time looking at the human eye. But then what I thought was unique in the way that Brother Dan approached this is typically you hear a class and they talk about, the eye is so complex, it's amazing, like there's no other way that it could have been created. And then the conversation just stops, and that's sort of like, this is the proof, and stops. And then you'll see different things from people in the scientific community and people who don't believe the same things that we do will then break down the eye and say, why it's not a good example. And Brother Dan touches on those arguments and then turns around and breaks those arguments down to make further arguments to support the idea that the eye actually is a really good example of God's creation and the wonder that is into it, which I found really interesting because I'd heard people use the eye as an example and go into some detail on the complexities of the eye, but never go into kind of the counter argument as to why the eye isn't a good example of a divinely inspired creation, and then broke that argument down and again reinforced that argument. So I just found it to be a really more in-depth look at the argument that sometimes people use when they look at the creation around us, to use it as an example to prove that God exists and that the creation we see around us is proof of his power in the world around us. So I really enjoyed this class. It was a fun one to just kind of dive into. I'm a little bit of a science nerd, so it was fun to listen to Brother Dan, and because it is his trade and his career, he was able to add a lot more depth than I feel a lot of other classes on a similar topic were, so it was a great one to listen to. This one came in as a suggestion that somebody had sent in that was at the Watchon Bible School and really enjoyed it and sent it our way. I'm glad they did. It was a great one to listen to. If you have any other suggestions or recommendations, even just speakers that you would like to hear more of, feel free to send it in. We've gotten some really encouraging feedback recently in the last couple weeks and months from people who are finding certain classes or topics or speakers to be really encouraging for them, and we love hearing about that. We're glad that it's something that is uplifting to everybody. I know myself and Levi, we've both been enjoying being able to listen to all of these classes and dig into them. It's been uplifting for us, and we hope it's been just as uplifting to you. With that, we're going to turn it over to our brother Dan Robinson for his evening program class, Stand Still and Consider the Wondrous Works of God.
I love this verse. And when you think about it, there's an awful lot to this verse. Every phrase is important. I wanted to put, capitals or highlights or make the text a little bigger for the important words. And as you can see, I've almost highlighted everything in the verse because it's all important. And in case you're not sure from the title, our class this evening is really to strengthen our conviction that God is the creator of the universe in which we live. The world is increasingly pushing God to the side, out of their minds. They teach evolution as a fact. It's an underlying assumption in almost every scientific article that's written about biology. And our class might be a little scientific. I don't think it'll be too challenging. We're just going to look at how complex the world we live in is. And I think it's rather ironic that at a time when there's an explosion of knowledge, where we have the technology to see the vastness of the universe and look down in minute detail at the complexity of every creature, and we've learned that things are thousands of times more complex than we ever thought, man is quick to leave God out of the equation. So where does this verse come from? It comes from the lips of Elihu in the book of Job. And you might be hesitant to take some verses out of Job, but there's nothing untrue about this statement that Job makes. If you'd like, just turn in your Bible to Job 37. I'll put it on the screen in case you find it difficult to look it up, but this is pretty important. Just read for you Job 37. I've left some of it off the screen, and so I'll have to turn it up here. It says, "Hearken unto this, O Job. Stand still and consider the wondrous works of God. Dost thou know when God disposed them and caused the light of his cloud to shine? Dost thou know the balancing of the clouds, the wondrous works of him which is perfect in knowledge?" And so we know Elihu's approach. He's trying to get Job to admit that he doesn't understand all the ways of God. And here his topic is something quite simple. It's the weather. And he says to Job, can you explain the clouds in the sky and the lightning and the rain? The NIV says, do you know how God lays his commandment upon them and causes the lightning of his cloud to shine? And I think that's a pretty valid question to anyone, even to scientists today. The more we learn, the more we realize we don't understand how these things happen. But you see what's repeated in these two verses again and again. It's the wondrous works of God, wonders that are perfect in knowledge. And there's so many wonders of creation, isn't there? The wonders of everyday life. Romans says there's so many wonders in the world about us that man is without excuse, that everyone should believe in God by just looking at the things that have been created. And those wondrous works, I looked it up to see what it meant, and almost every translation has the same thing. But Strong's Dictionary is a little bit helpful. It tells us sort of the color of the language. It means to be separate. The works of God are different than the works of anyone else. They're distinguished. You can tell that they're God's and not man's. They're great. They're difficult. They're wonderful. So the idea of things that no other person could accomplish. And presumably this is the argument of Elihu. Job, watch what you're saying. There's proof all around you that God is all-knowing and he knows what he's doing. And who are we to question him? That same word in Hebrew, pala, is in Psalm 139, which we did for our reading. Just turn over to Psalm 139. This is a really interesting section of Scripture when you look at the Hebrew words. It says in verse 13, "Thou hast possessed my reins, thou hast covered me in my mother's womb. I will praise thee, for I am fearfully and wonderfully made. Marvelous," that's that word about wondrous. "Marvelous are thy works, and that my soul knoweth right well. My substance was not hid from thee when I was made in secret and curiously wrought in the lowest parts of the earth." And so specifically, the psalmist is talking about the creation of a child in the womb. You know, how can anyone understand that? It's so marvelous. It's beyond understanding how a single cell becomes, a baby that's born 9 months later. Everyone, the psalmist says, should understand this. And you've got to love the beauty of the Hebrew language. In verse 13, where it says, "covered me." In Rotherham's, it says, "Thou didst weave me together in the womb." The ESV said, "You knitted me together in my mother's womb." And that's applicable to all children, but particularly applicable to Christ, who is the subject. And then in verse 15, the word curiously wrought is to embroider. And so you can just picture the fine embroidery that's done that becomes who we are when we're born. Some have actually suggested that this language sounds a bit like the twisting together of two fibers of DNA. And if you read the section very closely, it sounds like all the instructions of how a person is made are written in the twisting together of the DNA strands. But that's uncertain, of course. But the point is that when we look at things that are around us, especially the creation, we see the power of God. And what Elihu is telling Job is to stand still. That was our exhortation last night, wasn't it? We move so quickly, we often don't take a moment just to meditate upon the things that God has done. And we're going to do that tonight. We're going to look at some of God's creation. Just sit back for an hour, look at the complexity of what God has made, and marvel at his power. And we want to consider. And again, we'll just look at that word there, consider. It means to just take some time to mentally think about, to meditate upon, to attend, to discern, to look well to perceive. That's how it's translated elsewhere. And I was planning on showing you a lot of things that God created, but I kind of got stuck on what I think is the most incredible thing that God has made. And you're probably able to guess what that might be. It would be your eye. That is an extreme close-up of a part of the eye called the iris. And I chose this picture because there was a moment in my life where I did exactly what Elihu advised Job to do. I'm in my first year of optometry school, and we're in a lab on the second floor with other students, and we have these microscopes where you can look at the eye. And it was the very first time I got to look at an eye, a living eye, up close with a microscope. And this is what I use every day to look at people's eyes. And I'd never looked at anything like this so close that was living. Because I've looked in microscopes and you could see things that were dead. But when you look at the eye under the microscope, there's all these hills and valleys and folds. It's all different colors. You think of your eye being one color, but there's all different shades of color. It was in 3D. It's intricate. That black hole in the middle that you see that's like in a camera has a lens behind it that you can't see in the picture. But the best part was that while I was looking at it, everything is moving. When you move the light to the pupil gets smaller. And then when you move it away, it gets larger. So not are you only looking at a picture like this, but it's moving. It's really hard to describe what it looked like, but it made me stop. And I thought, I think I'm the only person probably in this room that's thinking that this was created by God. And everyone else thought that this just kind of happened. And what occurred to me is actually this part of the eye is a muscle. We'd learned that in class, but there's actually two muscles in this part of the eye, the iris. There's a circular muscle here that when it contracts makes the pupil smaller. And then there's all these muscles that run laterally. And when they contract, that makes the pupil bigger. So this happens all day long as you're looking at things. The pupil gets bigger and smaller to control the amount of light that comes into your eye. It actually responds to your emotion. It responds to how close an object is. It responds to those little stingy drops we put in your eyes when you go for an eye exam and make you blurry. And I just wanted to recreate for you that moment I had 20 years ago. And I've built it up pretty big. I don't know that it'll work, but this is a video, if it works here, of the eye up close moving. Hopefully that doesn't gross anyone out. Come on, you have two of them and they're doing this all day long. It can't be that bad. But you notice the pupil getting bigger and smaller? That's the muscles working. And as the pupil gets smaller, the iris tissue thins out, and as it gets bigger, it gets thicker. I'm going to turn that off just in case it is grossing you out. The blink that you were looking at, that happens in 1/10 of a second. And on average, we blink about 10 times a minute, except when you're staring at your devices when you only do it about 5 times a minute and your eyes dry out. And that color of the eye depends on a whole bunch of genes. Most children of European descent are born with light-colored eyes, almost blue. And by 6 months, 3 to 6 months, the darker pigment forms if it's going to, and you usually know the eye color of a child. And there's up to 15 different genes that decide that. So no matter what color eyes your parents have, you can have children with different color eyes. Anyways, I'm looking at this under the microscope, and I'm thinking, none of my classmates believe that this intricate structure is made by God. Well, there's a lot to the eye, and I think you need a quick anatomy lesson here. It took me a long time to find a picture that had that few labels on it, because I didn't want to overwhelm you. But you've got the front of the eye, where you'd stick a contact on your eye called the cornea. You've got a hole called the pupil. This is grade 4 or 5, right? The lens, and then at the back of the eye called the retina, which is like the film of your camera. And then there's a nerve that goes out the back, and we're going to talk about some of these tonight. So if you're thinking like a camera, you've got the pupil, which is the aperture. You've got the cornea and lens, which is focusing the camera. The retina is like the digital sensor, and the nerve is like the USB cable that goes to your computer. And your brain is like Photoshop, okay? So that's really what's happening with this here. And just give you some interesting facts about the eye. This is a photograph of the retina. That's like the sensor of your camera. Film, for those of you that are older, the film at the back. And every eye has about 7 million cones, which allow you to see in the day. And there's 3 different types of them that allow you to see in color. So if you only have 2 types of cones, you're not going to see colors the same way as everyone else, and you'll be somewhat colorblind. There's got to be some males here that are colorblind, because 1 in 12 males has some color vision deficiency. That's why we have trouble with, clothes and stuff like that. But less than 1 in 200 women have color deficiencies, and it's all to do with genetics. And then you've got 120 million rods, which allow you to see at night and pick up motion. Okay? And some of the processing of what you see actually happens in this tissue. The nerves actually connect before they go to the brain. And then that yellow circle there, that is 1.2 million nerve fibers going out the back of your eye, connecting your eye to the brain. And because the nerve goes out in that yellow circle, you have what's called a blind spot, okay? There's no rods or cones in that optic nerve. So if you were to close one eye and hold something in a certain spot about here, it would sort of disappear. It's hard to do because your brain actually fills in most of the detail. Most of your vision is in that little dark circle there in the middle. That's your best vision. That's where, when you're looking at something, the light focuses on the back of the eye. And it's called the macula. You've heard of macular degeneration, perhaps, some of the older members, or we'd know people in our family with that disease. And in that area, for every square millimeter, there's 140,000 cones, little cells that detect light. And if you've got a retina display, in that same area, you've got 139 pixels. So your eye has 140,000 cones, and your retinal display has 139 pixels. Not really retina, is it? But that's what they call it. And the rods that you see at night are actually focused about 15 degrees off to the side. So if you were looking at a star at night and look right at it, it might kind of disappear. But if you look off to the side about 15 degrees, you'll see it much better, because that's where your nighttime vision is focused. You've got muscles that control your eye. You've got the ones you think about, right, left, up, down, and a couple that turn the eye in different directions. They help give us a view of the world that's better than the 180 degrees that we think about. And they're quite interesting. Have you ever watched someone that's really quite poor at doing home movies? And everything's moving all the time, and you sort of start feeling nauseous? You ever thought why your vision isn't like that when you're running down the road and everything stays in the right spot? Well, your eyes are hooked up to sensors in your ears that send how you're moving and adjust for eye movements to compensate that in real time. That's way better than any camcorder has. And your eye does this automatically. And these muscles never get tired. They're not like muscles where you're running and by the end of the day, you don't want to move your eyes anymore. The other interesting thing is that, remember that small area with lots of cones in it called the macula? Well, that's our best vision, but we actually see the whole world because our eyes constantly are moving, and the brain puts all the pictures together and gives us this full view. That's why when you take a picture and you show it to someone else, it doesn't quite capture Like if you've been to the Grand Canyon, you can't quite capture the Grand Canyon on film or in a picture as it is in real life, because our eyes just do a much better job at taking in the whole picture. So those are just some of the things that make me marvel at the creation of God. There was a wise man named Solomon who said, "The hearing ear and the seeing eye, the Lord hath made both of them." So when we look at some beautiful lake or a mighty tree, or we look at the intricacy of a bird in flight, we can marvel at God's creation, but we should also marvel that he's given us the eyesight, the complexity of our eye in order to be able to see it. But God gives us sight for another reason. In Psalm 94, it says, "He that planted the ear, shall he not hear? And he that formed the eye, shall he not see?" I think there's a bit of a warning there for us, isn't there? Reminding us that if we have this ability to see things, surely God can see. And it would be absurd to say that God is blind. But there's people that do. And perhaps those people are us if we do things thinking that God isn't watching us. And we might say that by our actions. If you were to look at the context of this verse, you'll see that it's the wicked that would say that the Lord shall not see. But there are some people that actually say this literally, and we'll talk about that in a moment. It also says in Psalm 94, verse 8, that people who say that are brutish. And Strong says that means that they're senseless. They don't have their senses, and they're thinking that God doesn't see. So there's some pretty good spiritual lessons that we can look at. You could do a good class on whether our spiritual vision is 20/20, like we like to have. Well, our last verse for this evening is from 1 Kings chapter 4. And we think about the wisdom of Solomon. We think of his Proverbs. We think of how important the fear of the Lord is. But it appears that God also gave Solomon a little bit of understanding about biology. He spoke of trees and the cedar tree, spoke of hyssop. He spoke of beasts and of fowls and of creeping things and of fishes. And when he looked at all these things, he would have been impressed with the creative power of God. And I think, well, how much more impressed should we be that we can, put pictures of this up on the screen, and we can look at the eye in great detail with huge magnification. And we should be impressed with his limitless power. And the observations that we are going to make this evening, I just don't think fit in with the concept of evolution. There's so many different eyes in nature. How did they evolve so many times? How is it that each eye is perfectly suited to its environment? And how did things that are so complex appear without a creator? And there's actually a lot of scientists that are ready to admit that evolution does not provide the answers. So I'm going to share with you some of the eyes in nature. So that is a box jellyfish. And it's called a box jellyfish because it's shaped like a box. And most of them are venomous. They live, of course, in our oceans. And these jellyfish are carnivores. They actually hunt little fish. They can move up to 4 miles an hour. And unlike other jellyfish, which only have simple eyes, these jellyfish have eyes with a cornea and a lens and a retina. And it has 24 eyes, actually, in groups of 6. So there's 4 dark spots that you can see there. And in each of those dark spots, there's 6 eyes. And 4 of them are really simple. They just detect light. And 2 of them are complex and have this structure like our eyes have. One looks up and one looks down, and it allows it to distinguish between light and dark. It helps it have directional swimming. It helps it hunt its prey. That's kind of interesting. That's a fruit fly, okay? They're like 2 or 3 millimeters in size. And those red circles on the side of it are the eyes of the fruit fly. And it's very different than our eyes. They're called compound eyes. So instead of being one eye, that fruit fly, each of its eyes has 1,000 different sections that are just all individual eyes. And even though they only live about 40 days, they're very complicated, the vision of the fruit fly. Here's an electron microscope picture of some of the sections of the eye of the fruit fly. So there's thousands of these elements that actually focus light. And you know what? It's better than our eye in many ways because it can see almost 360 degrees. It has a much better field of view. It's way better at motion detection. As you know, when you try to swat a fly, it somehow senses that you're moving before you even think to move. It can detect polarized light. It can detect its position on Earth like GPS. And you wonder what those little spikes are that come out between every eye? They're actually called setae, and they're little hairs, and they slow down the evaporation so the eyes don't dry out as quickly on the fruit fly. They also reduce dust getting in the eye of a fruit fly since it doesn't have eyelids. Pretty incredible, the structure in just these little animals. Anyone know what that is? It's a cuttlefish. Yeah, it's in the same class as an octopus and a squid. And these guys can grow up to 23 pounds. The Greeks and Romans actually gathered them for the pigment that came out of it. It's a brown pigment that it ejects when it's excited, and it's called sepia. That's the brown pigment, or sepia. I don't know how you pronounce it in BC. I don't know how you pronounce it in Ontario either, but this has a bone inside it called the cuttle bone, and if any of you have birds, that's sometimes the bone that they put inside bird cages that birds use to get a source of calcium. And it's actually considered one of the most intelligent of creatures because it has a large brain-to-body ratio. And I don't know if you've ever seen cuttlefish, but they actually can change color. So I have a video of the cuttlefish that's just absolutely incredible from the BBC.
The cuttlefish has taken camouflage to the next level. They can change their color, shape, and texture to blend in with the background. It's hard to believe it looking at these pictures, but all these cuttlefish are exactly the same species. They're simply changing their appearance depending on what's around them. It's called adaptive camouflage, and it's perfect for hiding from both predators and prey.
Isn't that amazing? The first time I didn't even see it there, and then it jumps out for the fish. So not only do they have remarkable eyes that we'll come to in a minute, but their skin is incredible. It's got these thousands of sacs filled with pigment, and there's different colored pigments, and there's muscles on the cuttlefish skin that open up different sections, and it's like an LCD screen. You know, your screen on your computer, it can create different patterns with the muscles, allowing different pigments to be expressed. Okay? It's complicated. It's too complicated for me to understand or explain the layers of cells that allow it to create this color. But what's interesting is their eyes, and they have a different type of eye, which we'll talk about towards the end, that has no blind spot. And what's surprising about the cuttlefish is that it uses its skin not just for camouflage, but they think that it uses its skin to communicate with other cuttlefish with different patterns, that it can communicate that way. And I guess what's remarkable about it is that if you've got a fish that's depending on seeing different colors, you think its vision would have really good color vision. But they only have one type of cone in their retinas. So how do they see the color? Well, scientists think it has to do with the pupil of the cuttlefish. So that's a cuttlefish eye close up, and that W is the pupil of the cuttlefish. And that pupil is not a very great shape of pupil in order to focus an image. I don't know if any of you do photography, but it creates an awful lot of what's called chromatic aberration. So if you've got a camera and it has chromatic aberration, it means you've got color fringes all around the picture. Not each color is in a different focus, so it's not a very clear picture for us. So you want a lens that doesn't have chromatic aberration. But if you're a cuttlefish that depends on communicating by seeing the color on other cuttlefish skin, you want chromatic aberration because you can interpret the blur of different colors and thus see colors by doing that. And God's given the cuttlefish this very strange pupil, perhaps for that reason, if scientists understand it correctly. So I just think that's amazing. I'm really glad that wasn't what I was looking at in the microscope that day at school, because that might have been a little creepy. So does that point to you to a creator where the eye is perfectly matched to its environment, or does it point to evolution? That is a bay scallop. That's what you eat if you eat scallops. You eat one of the mussels inside this shell, and they farm them in Florida, and that's what you eat at seafoods places. But do you see those blue circles? Hundreds of them? Those are eyes. The scallop has eyes. I didn't know that. I must have missed that day at school. That's a close-up of the eyes of a scallop. And they have these very bright blue colors because of something called guanine crystals. And they call them simple eyes, but they're really not that simple, actually, because they have a cornea, they have a retina, and behind the retina there's a mirror. That's the blue part. And the retina works in two ways. The light goes through it, and it senses light. It reflects off the mirror, bounces back through, and that detects contrast. And the scallop can actually see, not really well, but it can tell differences between contrast between shelves on the ocean floor, how murky the water is, and that helps it to do its hunting and detect predators. Kind of an interesting set of eyes. That's a shrimp, a mantis shrimp, a crustacean that lives in rivers and oceans. And you don't see this very often, at least I've never seen one, because I guess it hides in the sediment at the bottom of rivers. And it has a compound eye like the house flies or like the fruit fly that we looked at before. But in each eye, there's over 10,000 sections or units of its eye. And these eyes, as you can probably guess, can look in different directions. One can turn one way and the other can look the other way. And it has completely 360-degree vision as a result. But this animal has between 12 and 16 different cones to see different colors. So, we think we see color well. The mantis shrimp can see all sorts of colors. It can see the UV spectrum. It can see polarized light. And they think that it has all these cones not to help it distinguish colors better, but it doesn't have the brain to interpret it like we do. So it interprets color by having different sensors, and it doesn't need as much processing power to see the colors. I just had to include that picture because it was really strange. Okay, the next few slides, it's guess the animal, okay? What do we think that is? Yeah, what do you think? It's a goat. You guys were getting scared. What's different about it? Its pupil is rectangular. Yeah. Ours are round. The cuttlefish have nice W's. And this one is rectangular. And it gives it better peripheral vision for watching for prey when it's grazing. And it blocks out more of the light from above because it doesn't need to see up. And the sun would desensitize its retina. And it has great ability to rotate its head so that when it's in different positions grazing, those eyes stay parallel with the ground very well because it's well suited for that. A chameleon, yes, which is a type of lizard. So the two answers I heard were absolutely correct. And some chameleons can change color. I don't know if they change as well as those cuttlefish. But they have really good eyesight, these chameleons. They can see UV light. They can detect little insects 10 meters away. And you'll notice something here. The eyelid is actually fused to the cornea. So it doesn't open and close its eyes. It's just fused there. And there's a few reasons for that. One is it's better camouflage. Rather than having a big eye, the skin comes right up. It also gives it better focus because it's got a small pupil. Like a camera, when we have a small aperture, we get a better focus on our camera. And the eyes can move independently. So one can be looking at the prey that it wants to get. and the other can be moving all around and surveying, for predators or things that want to attack it. And the eyes bulge out a little bit to give it a better field of view, and it actually has a special lens that lets it have depth perception with only one eye looking at something. So I can judge how far something is because my two eyes are getting different pictures of it. And the brain interprets that and gives me depth perception. That's how we can hit a baseball pretty well, because we can judge how far it is. Well, this eye has been specially designed because it needs to be looking in different directions, that the lens gives it two different, focuses, and the brain interprets that as depth perception. And it also has a lens that's designed very different and is more like a telephoto lens, which is really cool. What is that? It's a gecko. A gargoyle gecko. Yeah, that's really good. I think it's neat because the iris kind of blends in with the skin, doesn't it? It's got that cool design for camouflage. Again, not an eye that I really wanted to look at in school in the microscope, but what's different about this eye? It's got a vertical slit for a pupil. It also has cones that are 350 times more sensitive than ours. So our cones don't work at night. We use our rods to see. Those are the cells that detect light. This animal, its cones can see at night. And that's because its cones are really much bigger in the retina. And this is actually the pupil of a gecko open really wide. In bright light, this is what happens to the pupil of a gecko. It shrinks down. But isn't that weird? There's 4 little pinholes in its pupil. And you think, well, why would there be 4 pinholes, 4 pupils? In fact, if you had 4 pupils like that, you would see 4 of everything. Okay, which wouldn't be really all that handy. Especially if a truck's coming towards you or something like that. But the gecko behind this iris has a lens with 4 different sections to it. And because its eyeball is so short, all the colors would be out of focus for it. So it has a lens that's multifocal that allows different colors to focus independently. And it can actually then see much, much clearer. And it also allows it to be more camouflaged. There's also another cool thing about geckos is they don't have eyelids, and they don't have those little hairs poking out of them like the fruit fly. So their eyes would dry out. So there's this remarkable development, and I think this has got to be one of the greatest designs ever to keep the pupil moist. It licks its eye with its tongue. Why not? Otherwise, its eye would dry out. Oh. I don't know. I think there's no end to the complexity and the variety of eyes that God has created. Don't you think it's amazing that God has given us this wonderful proof of his existence? And I just wish scientists might stand still and consider what they're looking at sometime and take the advice of Romans and be without excuse, because really there's no excuse to believe in the God that we have. Now, I really haven't made much of a scientific argument. I've just given you examples of the wonderful creatures that exist upon earth. And I allow you to come to your own conclusion. I know your conclusion, but this argument that I'm making actually has a name. And the argument for creation that I'm making is an argument, it's called an argument from design. It's actually called the teleological argument. So in other words, we believe in God when we look at, well, we believe in God for lots of reasons, but we point to the complexity of nature and we say there must be a God that exists. And this is best illustrated in something you've probably heard of in classes before, called the watchmaker analogy. So anyone finding a pocket watch in a field will recognize that it was designed intelligently. Okay, so if you walked along the path and you came upon an old-fashioned pocket watch like this and you looked at all the gears and you spun it and the gears started moving and it kept time, are you going to think that that just happened to be there? Or are you going to think that there was someone intelligent that designed and built a watch? Okay. So that's the watchmaker argument. It says when we look at living beings that are similarly complex, or I think I would say, we've got a couple hundred years on William Paley, who was the scientist who put this argument forward. When we see things that are much, much more complex, that can recreate themselves, reproduce themselves, then that must be the work of an intelligent designer. Well, evolutionists, of course, have a counter-argument, and their argument is called an argument from poor design, okay? And they call this the dysteleological argument. In other words, the opposite. So what they say is that if you can see anything in nature that doesn't have a very good design, that would be evidence that it wasn't created by an omnipotent, all-knowing, all-powerful God. So, for example, you've got an appendix. You can have it out and there's no problem. So why would we have an appendix? Humans cannot synthesize vitamin C. If we didn't eat vitamin C, we wouldn't survive. We have to eat it. We can't make it ourselves, and I guess I didn't know this, but most plants and animals can make vitamin C. They don't have to eat it. Whales and dolphins breathe air but live in the ocean. Like, why would you have that kind of a design if you live in the ocean? So they're talking about suboptimal designs. Plants are green and not black. If plants were black, they would absorb more light, and they would be better at producing and growing and getting energy from the sun. So their argument is this. They say, if there was an omnipotent, omniscient, omnibenevolent creator God would create organisms that have optimal design, we see organisms that are suboptimal. Therefore, either God didn't create these organisms or God is not omnipotent, omniscient, and omnibenevolent. Now, I've been in a lot of baptismal interviews, and we've never talked about omnibenevolent. We always talk about the other ones, omniscient. They forgot how they have omnipotent. What am I missing? Omnipresent, I guess, is the one that we have, isn't it? Yeah. So they're wrong off the bat that God isn't omnibenevolent. That's where we get into trouble with people understanding suffering and difficulties that come into our life. So that's perhaps one step that they go wrong. But of course, they also are misjudging the things that God creates. So you've heard of Richard Dawkins. He's a scientist, and he wrote a book called The Blind Watchmaker. First, I thought he was calling God blind, but of course he doesn't believe in God. So what he's saying is that watch, that argument that William Paley made a couple hundred years ago, could be explained by a blind process called evolution. Okay, so that watch could be there if we had something like natural selection. And this is what Richard Dawkins says in his book about the eye, because the eye happens to be one of their favorite targets. He says, an engineer would naturally assume that the photocells, that would be the rods and cones in your retina, would point toward the light with their wires leading backwards toward the brain. He would laugh at any suggestion that the photocells might point away from the light, with their wires departing on the side nearest the light. Okay, now that might be complicated. But what he's saying is if you were making a camera, you would want the sensor to have direct contact with the light and have the cables that come out of it behind it so that they don't get in the way. Okay? Would it make sense to have all your cables in front of the light sensor in your camera? You know, they block the light from getting to the sensor. And in that sense, he's very right. So when you look at the design of us on your left, and squid and cuttlefish and octopus on the right, you can see that in our eyes, all the wires that come out of the cells that detect light come out the front part, get in the way of the light, and they actually run along the front surface of that, and at some point they have to curve out and go out the back of our eye, and they create a blind spot. So evolutionists say, well, if God had created the eye, he wouldn't have made it that way, because then there wouldn't be a blind spot, and the fibers wouldn't get in the way. All right? That's their thinking, and that's their argument. So here's just a little bit of lesson from optometry school. You've seen this picture of your retina. That yellow circle is the optic nerve, and that's the nerve fibers heading out the back of your eye. On the lower section is actually a description of all the little nerve fibers that are actually running in front of the cells that detect light joining together at that circle and going out the back of the eye. And there's 1.2 million nerve fibers. And if you do what's called a peripheral vision test on a person, and you cover their one eye, and you flash little lights in front of them, and they click a button every time they see it, that picture up there is what you get, where there's a black circle where they don't see lights. And you can see how that black circle perfectly corresponds with the nerve leaving the back of the eye. So they're absolutely right in that we have a blind spot as a result of that. That doesn't happen in the cephalopod, in the octopus or the cuttlefish. And Dawkins says if God had have created it, all the eyes would be like this octopus eye. And you think, that kind of makes sense. But you know what? That diagram doesn't even do it justice, because really what those wires do in the eye is they come out. These are where the light is sensed, right here. That's where the light has to get to. And then the message travels up here, joins some other cells, and then the fibers go to the brain. So the light has to get through all of that to be sensed by your retina. That's a lot of interference for the light, isn't it? And you think, well, why would God make it that way? In fact, it's even more incredible when you start looking at pictures instead of diagrams. This is actually a picture I can see in my office now. We have a machine called an OCT. It's almost like an MRI of the back of the eye. And anyone who comes into the office, we can look at their retina in this detail and see all the different layers of the retina. And the light has to get through all this and get down to this layer right here where it's sensed. And then this is all the processing that goes on. And that's all in the way of the light getting through to the back of your eye. And that also might not look all that bad until you see what it is like with an electron microscope. That's all the tissue that the light has to get through to get to the rods and cones, which are right down here. So, these scientists might be right. Why in the world would God make our eyes like this? You know what they call it? They say that the eye was made inside out. The retina was inside out to the way that it should have been designed. This is a quote from an evolutionist in 2005. Although the design of the eye is brilliant, it betrays its origin with a telltale flaw. The retina is inside out. The nerve fibers that carry the signals from the eye's rods and cones, which sense light and color, lie on top of them and have to plunge through a large hole in the retina to get to the brain, creating a blind spot. No intelligent designer would put such a clumsy arrangement, now he's speaking about a camcorder, in a camcorder, and it's true because it wouldn't work. And this is just one of hundreds of accidents frozen in evolutionary history that confirm the mindlessness of the historical process. And so they look at that and say, that's not the way it should be designed, hence God couldn't have done it. It must have been done by a series of chances and mutations and all sorts of complicated jargon to get to this. It's incredible. They're calling into question the creator of the universe. And our eyes, I guess, are an accident of evolution. One of millions of accidents when you think about it. Okay, so that's the science viewpoint. But really what we found out is that they're not quite right. Because if we take another picture of the eye, and we're just displaying it a different way, you can see all the rods and cones there in those nice colors. Those rods and cones are embedded in something called the retinal pigment epithelium. There's going to be a test before you can leave. Okay, we'll call it the RPE. That's what we call it anyways. We can't even remember those other words. So it's called the RPE. And it actually turns out that there's a very good reason why our eyes or our retinas are inside out. Would anyone here admit that we live a different life than cuttlefish? Yeah, they live in the ocean. They kind of have very specific needs for their eyes, but we have very different eyes. And those rods and cones that detect light are really high maintenance cells. And remember, there's over 125 million rods and cones that we see with. So underneath the rods and cones, there's a very important layer called the RPE, and below it, a huge network of blood vessels like nowhere else in the body, because the eye needs more energy than anywhere else. And in fact, it needs a way to get rid of all the heat that the eye produces. And it's important that this layer is in contact with the rods and cones. And you know what that layer is? It's completely opaque. No light would get through it whatsoever. So it's got to be in this position, because this is what rods and cones look like. And the part that detects light are those little discs at the top of the rods and the cones. And every day, every rod and every cone in your eye sheds 10% of those discs. They don't work anymore. So they are shed off, and that layer that's underneath the rods and cones has to reprocess the photopigments. It has to break them down, make them reusable, and funnel them back to the cells so that it can recreate those discs so that they'll work. So every night as you go to sleep, the cones that have been working all day, 10% of them just break off and get reprocessed. And every morning when you wake up, 10% of the rod discs get reprocessed by that layer of the eye. Okay, that's about as complicated as my talk gets tonight, but this is important. So if God made our eye the way that they suggested, it wouldn't work. Because those rods and cones and those discs that come off, they'd have nowhere to go. They just go floating into that center part of our eye and eventually fill up the eye, and they wouldn't be reprocessed. Because we live in a very different world than octopus and cuttlefish. And in fact, their rods and cones are different. They don't do that. They don't have these discs that need to be reprocessed. But there's a little bit more. And this is my favorite part. Because there's these cells that when I went to school, they're called Mueller cells. And when I went to school, they described them as being support cells. They didn't really know why they were there. And so they said they were support, like pillars in a building. So they kind of held the ceiling up in the retina so that it didn't collapse. Well, you know what new research says about those cells? That they're like fiber optics. So running through the retina are millions of Mueller cells that run right from the top where the light hits all the way down to the rods and cones at the bottom. And when the light hits those Mueller cells, just like fiber optics that bring internet into your house, the light reflects back and forth through that cell and gets right to the bottom of the rods and cones. It's incredible. And they've been able to determine that these are perfectly designed in order to funnel that light to the layer of the retina where it's needed. So scientists who told us that our eyes were inside out were totally wrong. And I think they're going to find that out about everything that they look into. And they're eventually going to learn that God created this world and he created it the way it was meant to be. Well, what about the blind spot? And we'll just finish off with this. You know, they point to the blind spot as being a horrible thing, but you know what? You've got two eyes. And the one blind spot's over here and the other's over here. And your brain fills in the information from one eye and the other. But that's not all. If you were to cover one eye, if you did that and look up here, is there any part of your vision that's missing? Do you see anything? Anybody missing anything? No, because your brain actually analyzes all the detail around the blind spot. And like Photoshop, it fills it in instantly, all the time while you're working. And so God's given us a brain that processes the information. Brothers and sisters, I don't know about you, but we are truly wonderfully made. And we can't do any better than to echo these words from Psalm 139. I will praise thee, Heavenly Father, for I am fearfully and wonderfully made. The more science learns about the complexity of nature, even while they seek to explain away a creator with complex theories of evolution, you and I can rejoice that God's creative hand is in everything around us. Marvelous are the works of our Heavenly Father, and that my soul knoweth right well.
Thank you for listening to the Good Christadelphian Talks Podcast. Please subscribe for new episodes and leave a review on Apple Podcasts or whichever service you are listening from to help people find the show when they search for it. If you enjoyed this talk, share it on social media so other people can find it too. For show notes and links to the talk that you just listened to, visit our show page at anchor.fm/GCT. We want to encourage everyone to share their thoughts from the talk this week on Facebook or Instagram, where we are at Good Christadelphian Talks, or on Twitter, where we are at GCT_podcast. If you know of a great talk, we want to know about it too. Send a suggestion to goodchristadelphiantalks@gmail.com or message us on any of our social media platforms. Thank you for listening. God bless, and talk to you next week.